Hi everyone, welcome to today's YouTube video where we're going to see the geometric interpretation of multiplying complex numbers. First of all, we'll start by multiplying a complex number z with itself, so that if we multiply it with itself, we have z squared. For instance, let's assume that or recall that z is equal to, in complex notation, r into cos theta plus I sine theta. With this, we know, let's assume that the theta is somehow around 30 degrees. Let's say theta. This is z, this point, on a unit circle. Let's also assume that r, let the radius equals 1, so that r, to avoid ambiguity, becomes cos theta plus I sine theta. So what we are going to do now is to multiply the two and see what will happen to this line, this vector, this complex number. So if we multiply z times z, that is z squared, we will have cos theta plus I sine theta times cos theta plus I sine theta. So that we have multiply this with that, multiply that with this, multiply this, multiply that. If we do that, we will have something that looks like cos squared theta for this, for that will be plus I sine theta cos theta. This will give us also plus I sine theta cos theta. This one times this is I squared is minus 1 minus sine squared theta. So that's what we'll get. So we'll have cos squared theta minus sine squared theta plus this and this are the same. So it's I 2 sine theta cos theta. So you see now that this is now a real number for the new complex number that we have obtained, and this is the imaginary number. And this thing from trigonometrical ratio is just cos 2 theta plus I sine 2 theta. So geometrically, multiplying a complex number with itself will rotate this thing will rotate the vector by 2, by multiplying it by 2. So the rotation will be somewhere here, and here is another theta. So here is z squared. There is z squared. That's multiplying a complex number by itself rotates the vector twice the previous angle. That's what it means. So it has rotated this vector this way twice the previous angle. So what if we multiply again by another one, so that we have a z cube? So what it means is that we are going to do cos 2 theta plus I sine 2 theta times the normal vector, that's cos theta plus I sine theta. So if we multiply this with this, multiply that with that, so this multiply that with that, so what we will have is equal to, that z3 is equal to cos 2 theta cos theta. For this one we'll have plus I sine theta cos 2 theta, and for this one we'll have plus I sine 2 theta cos theta, and this one will have plus I squared sine, plus I squared is minus sine 2 theta sine theta. That's what we'll have. So that if we collect like terms, we'll have is equal to cos 2 theta cos theta minus sine 2 theta sine theta plus I, there are two i's here, so sine theta, this one sine theta cos 2 theta plus sine 2 theta cos theta, this one. So that's what we have. So by inspection you will see that this is just cos 2 theta plus theta, cos 2 theta plus theta, and this one is sine 2 theta plus theta by inspection. So that is equal to cos 3 theta plus I sine 3 theta. By inspection, this is cos 2 theta plus theta, and this one is sine 2 theta plus theta. So we have this. So it means now that that previous angle have been rotated by let me come back here, by 3. So let's say 30 is here now, z cube. So here is 30. Assuming that theta is 30 degrees, it will rotate it to the vertical axis, the imaginary axis. So that is what we have. But this is when our r is equal to 1. Our calculation is when r is equal to 1. Assuming that r is not equal to 1, that means if r is not equal to 1, therefore our z is r cos theta plus I sine theta, and that is our z squared will be, we have done the multiplication before, so our z squared, we have done the multiplication before, will be, look at our z squared here. Our z squared is this one, so it will be r squared, because we are multiplying r squared and this squared. So okay, let me just do it, r squared cos plus I squared theta squared. So we have done this before to get this, so just r squared cos 2 theta plus I sine 2 theta. That's what it will give. So that our z cube will be equal to, if we follow that same pattern, r cube into this guy is cos 3 theta plus I sine 3 theta, because we have done it to get z cube here when r is 1. So r is 1 cube. So in this case r is not 1, so it's r cube. So what is the implication is that the radii for the squared and the cubed is squared. This thing is squared, so that assuming you have something, you started with something like this, let's say it's 2, r is 2. So when you square it, it will be 4. When you cube it, it will be 8. When you cube it, it will be 2 times 2 times 2, it will be 8, and it will form something like this, in that order, to form something like that. So that is the implication. And with this thing, you can also prove from number 1, you can easily show that if z is equal to 2 plus I, if z is equal to 2 plus I, that it means that the radius here, that's the magnitude, modulus, is equal to square root of 4 plus 1, that's square root of 5. And therefore this z squared, it will be 2 plus I times 2 plus I. And you have, if you multiply them, you have 3 plus 4I. And the modulus in this case will be equal to square root of 5 all squared. That's 5, if you like 5. So that our z3 will also be 3 plus 4I times 2 plus I. I'm assuming now that you expect a multiplying distance, so you have 2 plus 11I, 2 plus 11I, and the radius, that means that the modulus will be square root of 5 all cubed. So this is how to do this. Please subscribe and click on the notification button so that whenever we post new video, you will see them. Bye.